This video is about half-planes and hemihyperplanes. Now, in the case of a half-plane, any segment of a plane that goes on forever is considered a half-plane. So it's not just, say, entire plane covered by positive ray values for the abscissa, the horizontal plane, but even a single quadrant. A single quadrant could qualify as a half plane, or even something, say, more restricted than a quadrant. Say like a 60-degree span with the vertex on origin or displaced from the origin, but any such wedge, right? We can put the vertex at the origin and call it a hyperplane. And conversely, all the rest of this plane, right? If we exclude one quadrant and take the other three quadrants, those three together could be considered a half plane. Okay, so we could take this concept and we can expand it to more dimensions. Say we had a three-dimensional hyperplane, right? Where we have three axes instead of two, right? Such a space defined by three axes rather than two would be three-dimensional, and it would divide it up instead of four quadrants in the case of a plane, we would have 8 octants in what we call a hyperplane of 3 dimensions, right? We have 3 axes, and the areas, the spaces defined by the positive and or negative rays of each of the 3 axes would give us octants. Okay, so any one of those octants would qualify as a hemihyperplane, as long as the space, the areas are adjacent, the adjacent octants or parts of octants are adjacent, they would be considered a single hemihyperplane. Any that are not adjacent, that are separate, would be considered separate hemihyperplanes. And of course, this concept extends to 4 dimensions or more, as we would define them by additional axes and the spaces that would be defined by the rays of those additional axes. Okay, hemihyperplanes.